You can use electrical resistance. You can use electrical conductivity. You can use electrical capacitance. All these different aspects of electricity that you can use as the mechanism for sensing. Now, in all these systems, the concept, as I said, is extremely simple. You have an electrode, and you have another electrode. Between the electrode, you have current. You have electrons that are moving in a current, in an electrical circuit. The unique thing about every sensor is what you have here. This is the chemistry. This is the nanotechnology. Here is the sensing material. And if you make the sensing materials very innovative and interesting and efficient and sensitive, then you can make a good sensor. So the sensing material, basically what it needs to do, it needs to absorb the pollutants from the air and tell you that there are pollutants. So for example, if you want to develop a sensor for carbon dioxide, for example, so again, you have the two electrodes connected through some kind of resistance meter, and then you have here the medium, which is the place where you can do your inventions and innovation. For example, you can put a nanomaterial layer that will absorb very well carbon dioxide molecule. In this case, this is your target. If you absorb the carbon dioxide molecules to your medium, it will change the properties of this medium, and you're going to have a change of the resistance. Okay? So all the story happens here, in the place where you absorb the gas molecules, the pollutant molecules, the nanoparticles, whatever is your target for detection. And if you absorb them well, if you have good sensitivity to the nanomaterial that you use, you're going to have a good sensor. So what I'm going to show you now, just few examples of sensors based on nanomaterials and nanoparticles. So this is an example of again, a simple sensor in which the sensing area is made of a thin layer of nanomaterial or nanoparticles. We have lots of nanoparticles here from different compositions. And what these nanoparticles need to do, they just need to have an affinity. They have to absorb, to bind the gas molecule. So the properties that you need for these nanoparticles are good interactions, good affinity with gas molecules. Now again, why nanoparticles are good for you? Because nanoparticles can give you a very good surface area, very high surface area. You want high surface area because you want to absorb your gas molecules. The more surface area, the better or the higher absorption of gas molecule. This is another example of a gas sensor. This particular gas sensor works on capacitance and resistance in the same time. And again, what you have here are some nanomaterials that attract, that absorb various gas targets In this case, it's H2S or tertiary decaying. It doesn't matter. The innovation or the activity is designing the film, designing the surface in order for it to absorb efficiently the gas molecules that you need. So that was the general description of nanoparticles and nanotechnology for gas sensing. Now, let me tell you about our work in the lab, in which we used an electronic nose based on carbon dots for smelling bacteria. Okay? The objective here is to be able to detect bacteria, to sense bacteria using the gas phase. Now, why is it important? In many cases, we have bacterial infections in various foods. These are just some articles from newspapers where you read that people go to the supermarket, they buy some food, the food is contaminated with bacteria, they eat the food and they can get very sick. This happens a lot of times. Now, in most cases, of course, there should be some regulation that there will not be bacteria in food, but in some cases there are contaminations of food with bacteria. So you want to develop a way to detect bacteria very efficiently and very quickly, for example, in food. If you will have a sensor that will be cheap, sensitive, easily applicable for bacteria in food, you can save lives, you can help people not getting sick, and of course you can open a business and sell it. There's also bacterial infection in hospitals. You know, in hospitals it's very dangerous to have bacteria when people are sick because they can get even more sick. So again, even in hospitals, in the walls of the hospitals, on tables, in instruments, surgery, you want to be able to detect bacteria quickly and efficiently. And surprisingly, there's not too many ways right now to do quick detection of bacteria. How do you diagnose bacteria? Usually what people do in hospitals, in labs for testing food, what they do, they take a sample, they put it on an agar plate, and they grow the bacteria. It takes 24 hours. It takes 48 hours. It takes a long time until, if there are bacteria, you can see them growing here. Sometimes you can see it through the colors that they make in certain dyes. But all these techniques are very slow. It takes a long time. And usually you do it in the lab. So it's complicated. You cannot take every meat or every vegetable that you buy in the supermarket and send it to a lab and they tell you there are bacteria or there's no bacteria. It's very inefficient. So if you can come up, if you can invent a very simple sensor for bacteria, it's going to be really useful. And that's really our objective. Our objective is to develop sensors that will be easy to use, that will be cheap, that will be efficient, that will be quick for detection of bacteria. Now, the nice thing about our approach is that we don't need